Howdo, and welcome to the electric TrakTrike project that I'm making for EMF Camp 2024. If you've not seen the previous videos, they're all linked below, and in this video I'm going to be creating the electronics, write some software, wiring everything up and hopefully giving the thing a try. Let's make a start. So using the excellent and free design spark, first of all I knocked up a schematic diagram, and from this I created a design for a printed circuit board. I loaded this PCB design into the excellent and free flat cam, which I used to create a toolpath for my CNC router so I can create my own PCB. With the output from flat cam, it's time to get onto the CNC and mill, drill and cut out the PCB. I know I can have them made in China, but it's so easy to make a board like this, it only takes about an hour. Why would I bother? And finally it's time to get the soldering iron out and get the components stuck down. Single sided board, tin copper wire on top. Looks okay. The electronics are going to be stored in a waterproof box fastened to a steel plate that's mounted onto the TrakTrike frame. First thing to do is subscribe around the box to get some cutting lines. Very quickly cut this plate to size using the jigsaw. Using a step drill, I created a couple of large holes in the bottom of the box and then fitted a couple of cable glands. The steel plate that the box is mounted on are fitted to a couple of angled plates on the TrakTrike frame. This should put the box at a nice angle for easy access when you're sitting on the track itself. I created a couple of large holes in the plate to allow the glands to poke through, and the box was fitted to the plate with some donuts. I used Fusion 360 to mock up the lid of the control box. There's an LCD display on there, a couple of voltmeters, a master switch, and I'm going to put a logo on there too. There it is, TrakTrike. I'm then going to use Fusion 360 to generate the G-code, which I'll then bang it into the CNC router to cut everything out for me. With the lid design complete, it's onto the CNC router to get the holes cut out and engrave the logo. To make the text stand out, I used some standard black acrylic paint, and with a blob of it on the lid of the box and a squeegee, I can force the paint into the profile left over by the CNC router. And when the paint's had a chance to dry, I sand off the excess with some very fine sandpaper. I also use a cork block for the flat surfaces just to make sure everything doesn't get gouged out again. And I'll be covering the text with a layer of spray on varnish. The control panel box has got a few LCD displays on there. There's two for battery stated indicators and a 16:2 character LCD display to show the current software status. There's also going to be a rotary encoder with a switch for menu navigation, a large power switch to allow you to cut off, and a push button for the lights that are going to be on the front eventually. Right. It's really windy outside and it's raining, so I can't put the gazebo up, but it just so happens that my nearest and dearest has gone to Australia for 7 weeks. This means I have nag-free kitchen access, so I have the TrakTrike set up. I'm going to leave it here for a few days while I do the wiring and hopefully we can get it sorted out. Okay, so now I can turn it on. It doesn't let the magic smoke out. There's only one thing left to do. So for a very first ride on test, I wanted somewhere dry, so I took it to my local makerspace, Hackspace Manchester. Just so the place was empty, it was early morning, no one's going to die, and it was then that I realised that I'd made two pretty serious mistakes on the design of this thing. There's a noticeable swing out there, and when I looked at this I realised that the tracks just weren't far enough apart. Also the suspension's quite soft, so that's just going to be a problem. The BBC also did a documentary on the perils of three wheels.
Oh no.
And this was confirmed when I employed my own test pilot. No, careful! That's what you gotta be careful. And the second problem is caused by the digital potentiometers. Under normal operation, the throttle will be at a value, say 20%, and that'll be read by the Arduino. The Arduino will then pass this onto the digital potentiometers, and then the speed controllers will read that value and set the speed accordingly. That's not a problem. If I go up to 80%, the Arduino reads that value, sets the digital potentiometers to that value, and you're going at 80% speed. The problem arises that if the Arduino dies, it's not reading the throttle, it's not writing new values to the digital potentiometer, but they're still at 80%, and that's the problem. If the Arduino crashes, the TrakTrike will just continue going at the last speed it was given. Right, so after the tests I've got a few problems. It's not wide enough, it topples over, and that's no good. I'm going to have to fix that. And also there's a problem with the motor speed controllers, in that if the Arduino ever crashes, it's quite likely that the motors will just carry on going at the last speed that they had, so that's no good. I'm going to have to address that too. Join me next time. Thanks, and please subscribe.